So, what we're looking at here is mathematical relationships, and we use this in physics all the time. This is a mathematical relationship. What is a relationship? Ryan, you're a big fan of home and away. Tell me what a relationship is. It's when two things interact with each other.
Yeah,
correct?
What's that? Oh, that's
It's like a... I'm trying to point out that the context in which we use relationship often in our world is similar but not the same as the relationship context in physics. And Home and Away is a common soap opera where relationships are often formed and fractured quite frequently. And that's the premise of the story. Now, what this is saying as far as a mathematical relationship is concerned, Mason, as my A value goes up, what would you expect to happen to my P value, providing everything else is kept the same? Goes up with it. If I double my A, what would you expect my P? Very good. If I half my A? Okay, very good. That's called a proportional change. Whatever I do to A, the proportionality happens to P. Does that make sense? We have another name for proportional relationship. Does anyone know what that is? Linear. Now in maths you've been looking at linear relationships, correct? Y equals mx plus c. It's exactly the same thing. Okay. If I double x, y would double, providing there's no c value. Let's just ignore the c value for now. Let's just keep that nice and steady. Happy with that? What is m then? Because I've just identified that a is the variable I'm changing, y is the one I'm investigating. What is m? Yeah, that's right. Yeah, I was just trying to give everyone else, but it was you two anyway. So, yep. You go, Logan. No, you're right. On your response. What's m?
Constant.
What's constant?
Gradient. It goes up.
Yep, the gradient. So in this equation, what would be my m value? What would be represented by m? Well, no, I'm doubling my a. So a is my x. So a is equal to x. P is equal to y. What is my m, Lulu?
K.
Just k?
Delta.
Delta t?
Oh, OG.
Very good. Because I said at the start, all of those things are constant. What is m? Constant. So that describes how much my values go up by. Are we clear? We used an example earlier in the term where we had V equals IR. Okay. I'm just going to assume that we had V was the Y, not the other way around, because we did have it the other way around. But let's assume V was the Y. So Y, I was my X. What was my R? Y equals? Mx plus c. There was no c value. So what does my m tell me?
How much has changed that value?
If I plotted all my data points, what would my m tell me? The resistance. My gradient would tell me my resistance. Does that make sense? Okay, let's say... Ready? Let's say I've got this data here, so I'll use it in a more reasonable context. Let's say I've got a volt pack jammed up and it's going 2, 4, 6. Okay, at 2 volts, I find I've got its volts there. No, I'm going the other way around. I want to go current. At 2 amps, I had 4 volts. At 4 volts, 4 amps I had 8 volts. And at 6, 12 volts. Happy with that? What's the gradient of my line? What's it going up by, everyone? M equals 2. Happy with that? What's the resistance?
2 ohms.
2 ohms.
Oh, yeah, I got it.
Does that make sense?
Yeah.
So anything that I'm keeping, because I'm assuming I'm keeping my resistance constant, anything I'm keeping constant can be represented by the gradient of my line. Very clear? That's far more valuable in a simple relationship like Ohm's law. Is it as valuable here?
Yes.
Not really, because we don't know what K, delta T and our thickness is. But if we tested those things and we found a linear relationship, if we changed A and found that it changed P in a straight line, what would that prove to us? Would that prove or disprove this function?
It changes.
If I didn't experiment,
Oh, yeah.
I doubled my A, I doubled my P.
Yeah, for you.
I tripled my A, I tripled my P. And then I was writing a discussion. Would my first sentence be the result supported the expected theoretical,
Yes.
or did it refute?
Supported.
Supported it, correct?
Yes.
If I found that it went up linearly and then tiered off a bit at the end, what would I say? Partially supported. And then what would I do?
Explain what.
Explain why it didn't. Does that make sense?
Yes.
That's using a linear relationship. We're all pretty confident with that. If I was